Hi guys, welcome back to my channel Pirai Academy. In the series of Zoho interview question, today we are going to see about a question called Decode Ways. So it is Leetcode question number 91. You have intercepted a secret message encoded as a string of numbers. The message is decoded via the following mapping. So what is the mapping? 1 is mapped to A, 2 is mapped to B, and 25 is mapped to Y, and 26 is mapped to Z. However, while decoding the message, you realize that there are many different ways you can decode the message because some codes are contained in other codes, like 2 and 5 versus 25, which means 2 will be equivalent to B and 5 is equivalent to E, so it will be forming BE, but this 25 will be forming this Y. Can you understand this? So these are the different types of decoding ways we can do in this 25 string. Okay, now for example, if it is 11106, then we can just decode it in two different groupings. What are those? It will be AAJF or else KJF. Okay, so the following grouping will be 1 1 10 6, here 11 10 6. Okay, but you may ask whether it is also a valid grouping 1 11 and 06. No, because 06 cannot be a valid because it having a leading 0, so it will be invalid. Fine. Okay, so given a string is containing only digits, return the number of ways to decode it. If the entire string cannot be decoded in any valid ways, then return 0. Okay, fine. Now let us go here. So these are the three examples they have given. So first of all, it is 1 and 2. Okay, if it is 12, then I can either decode in 1 2 or 12 as it is, because it can be AB or it can be L. Okay, so these are two different decode ways. So the answer will be what? 2. Hope you understand this. Now 2 to 6. Then here I can either decode in 2 and 26 or 22 and 6 or 2 2 and 6. Okay, so these are the following decoding ways. So it has 3 decoding ways. And then come here. So it is what? 06. Whether 06 can be decoded? No. No. Initially it is starting with the leading 0. So it has only 0 ways. Fine. So let me just go here. Fine. Now, what is the logic behind this? Fine. So it is basically like we want to tell them how many ways the given string can be decoded, right? So in this, we can either take one character or we can either take two characters. Why? Because the everything will be ranges from 1 to 26, right? So it will be either 1 digit or 2 digits. That's it, right? And in this 2 digit also, whatever the number which is greater than 26 will be invalid. Hope you understand these two logics. Okay, so come here. First of all, here I can take either this one, right? I can either take this one alone. Okay, if I take this one alone, then 2 will be remain constant. If I take this 1 and 2, whether 1 and 2 is 12, so 12 is less than or equal to 26, right? So it is also valid. So I will be taking this 1 and 2, then it will be empty string. Can you understand this? Okay. Now see here. If there is only one character that is left or only one number is left that is not equal to 0, then I can tell you that it will be forming me a one different way. If there is empty string, then I can tell you that it also forming a one different way, because this two strings will be deformed and giving me a empty string. Hope you understand this. Can you understand this? Listen this carefully. When you have only one string left over which is not equal to 0, then you will be yielding a resultant of one way. If there is nothing left over, then also you can tell me that the decoder way is 1. So 1 plus 1 will be 2. Hope you understand this, right? Now let me go with this so that you can just understand this clearly. So first of all, I can take this 2 alone. If I take this 2 alone, then what will be my result? It will be something like 26 will be remaining. Remaining will be 26 because 2 is valid, right? Now if can I take 22? Yes, I can take, because 22 is less than or equal to 26. So remaining will be 6. Fine. Now again here, whether I can take this 2? Yes, you can take this 2. If I take 2, it will be 6. Whether I can take 26? Yes, it is equal to 26, right? So it will be empty. Okay. Now see here carefully. Here there is only one string left over. Here there is only one string left over. So it will be of one way. Here it is empty. So here also I can say it will be one way. Here also only one string is present. Sorry, only one character is present. So it also one way. So totally of 3 ways we can decode this entire string. Can you understand this? Now comes a twist. Just listen this carefully. Now whether I can take this 0 alone? No. So whether I can take this 0, 6? No. So whenever I am encountering a character as 0, I directly put there itself as it will be 0. This whole string will be 0. Decoded ways. Okay. So from this itself we can say that it is a recursion and backtracking solution. So it is like we will be taking the first character and just moving the next character to the next recursion call. That will be my one recursion call, and then the second recursion call will be whether I can take the 2 characters if it is less than or equal to 26. Like I will be explaining you again with the same example, 2 to 6. Okay. Now I will be taking f of I, where f of I will be representing the function of anything like indices. Like if it is f of 0, then I will be here. Okay, fine. Now listen this carefully how this backtracking works. Okay, first of all, at f of 0, I will be just taking this 2 alone, right? I can take this 2 alone. Okay, if I take this 2 alone, then I can tell you that it will be f of 1. Okay, this 2 alone left over. Fine. Whether I can take this 2 and 2? Yes, you can take. So 2 and 2. Now it goes to what? F of 2. Can you understand this? Yes. Now, if it is f of 1, then my current pointer will be lying at here. Can you understand this? Yes. Now, at this point, I can take 2 alone or 26. So I will be taking 2 alone. If I take 2 alone, it will be f of 2. If I take 26, it will be f of f of 3. Right. Now just to see this carefully. When it is f of 2, my current pointer is lying at this point, 6, right? 6. Now it is a last character. And it is not equal to 0. Each and every time you want to check whether the current character is 0, or else only you want to proceed with this, right? Now the 6 is a last character. So I can say this function will be, this recursion call will be returning 1. And then this is the empty, right? 3 means it will be here, the length of the given string. Okay. So here also I will be returning what? 1. So here also I will be returning 1. Okay. Here it will be returning what? 2, because 1 plus 1 will be 2. Here f of 2 means it will be at the last character. So it also will be returning what? 1. So it will be returning 1. So 2 plus 1 will be 3. So this 2 to 6 will be returning 3. So this is how the recursion tree works. Okay, but actually the recursion works in a DFS manner, not BFS manner, which means listen this carefully, which means if it is 2 to 6, which is f of 0, then it will be going here to f of 1. Okay, again it will be going here to f of 2. Once it backtracks to 1 and return 1, then only it will be going to f of 3. Then it also returning backtrack and returning 1. Then this will be returning and just returning what? 2. Okay, then only it will be going here. It will be f of 2. Then it will be returning here as 1. Now only this f of 0 will be returning 3. Hope you understand. So this is BFS. I just taught this to understand the recursion tree. Okay, but the actual thing that is happening is this, the DFS. DFS means depth first search. Okay, not much important, just understand. Okay, So tell me, what is the time complexity? So time complexity will be O of 2 power n, and space complexity will be O of n, because we are taking a recursion. So recursion will be having a recursion stack. So it is because of the recursion stack. Hope you understand this. Okay, fine. Now let us see the code so that it will be more clear. Okay, first of all, we can see this code and we can go for optimization. Okay, fine. So I will prepare a Java code. So let me uncomment this. So this is the code for the recursion and backtracking approach, that exponential approach. Okay. Now this is the given function they have given. So I will be sending this function to the helper function. Okay, as 0 as my current index and s is the given string. Now here I will be checking whether I is equal to s dot length, which means if my current index is equal to the length of the given string, which means the actual string is empty. In this case, what should I return? I should be returning 1, right? Again, I want to check whether the current element or the current character is 0. Then I don't want to check anything. I just return what? 0. I will be telling this example, okay, after explaining this entire code. Okay, just wait. Now if I is equal to s dot length of -1, which means if the current index is a last character, then what should I do? I should be returning 1. Okay, now int single, which means I am taking only one character. If I taking only one character, then what will be my next function call or recursion call? It will be decode of I plus 1 comma s, which means I am just stepping over one step, not 2 steps. Okay. Now int double digit is equal to 0. String pair is equal to s dot substring of I comma I plus 2, which means I am taking two characters. I am taking 2 characters. For example, if it is 2 to 6, then I can take either 2, that is single. Okay, for double, I want to take what? 2 and 2. So 22 will be taken, right? And I am checking whether the 22 is greater than 10 and less than 26. Can you understand this? Yes. If it is so, then I want to do what? I want to just go for recursion call for I plus 2. Hope you understand this. Now at last I will be returning what? Single plus double digit. Fine. So if I submit this, it will be showing me a time complexity error, because this approach is 2 power n. So what is my maximum length? It will be 100, right? Yes, see here, time limit exceeded. So it is what? 100. So 2 power 100 will be exceeding my general time complexity limit of 10 power 9. So that will be my maximum limit, will be given in Leetcode. Okay, and in any platform. So it will be reaching that limit and it will be showing me time complexity error. Now how we are going to just optimize this? Before that, I will be showing you something like 11106. So I want to exactly show this example so that you can understand this clearly. Okay, so 11106. So just understand this clearly. This is what? F of 0. Okay, now I will be just going and taking only one string. If I taking only one string, it will be what? This one alone. If I take this, it will be f of 1. Hope you understand this. Now I can take this 2 string. Yes, it is not equal to 0, and also it is greater than 10 and less than 26, less than or equal to 26. So I can take it. So if I take this, it will be f of 2. Now just understand, I am not going in a way of DFS. I am just explaining you in a recursion tree of BFS. So it will be easy to understand for you. Fine, just come up with me. Don't just leave anything, just come up with me. Now it is f of 1. F of 1 means I am standing where? Here. Right, f of 1 means. So from here, where should I go? I can take this 1 alone. If I take this 1 alone, it will be f of 2. Right? If I don't take this 1, I can take 1 and 1. So it is also valid. So I can go for f of 3 after taking this 11. Okay. Now f of 2. F of 2 means I am here. I can either take this 1 alone. So if I take this 1 alone, it will be f of 3. Or I can take this 1 and 0. So if I take this, it is valid because it is greater than or equal to 10. right? So it is equal to 10, so it is valid. So if it is valid, then I will be going to f of 4. F of 4 means 0, 1, 2, 3, 4. So I will be here, something like here at 6. Okay, okay, fine. Now what is f of 2? F of 2 means here. So from here I can go to what? I can go to either f of 3 or f of 4. Both are valid because one is valid and 1, 0 are valid, right? So let me change the color so that it will be more clear. Fine. Now either I can go to f of 3 or I can go to f of 4, right? For this f of 3 means I am here. Whether I can go with 0? No. Whenever the current element is 0, just stop here and return what? 0. So stop here and return what? 0. So let us first complete everything and go after that. Okay, fine, fine, fine. Now here also f of 3. So this is also similarly equal to 0. Okay, now f of 4. F of 4 means it is here. It is a last digit. It is a last digit. So sorry, last character. So it will be returning what? 1. Now here also this f of 4 is a last character. So it will be returning 1. Here also f of 3, it will be returning 0. Now 0 plus 1 will be 1. Now 1 plus 0 will be 1. Okay, here also 0 plus 1 will be 1. 1 plus 1 will be 2. So the answer is 2. Hope you understand up to this. Okay, okay. So this is the normal recursion call. But whether you have checked these things, for f of 2, I have calculated here and also here. Okay, fine. So here comes a contradiction, like whether we want to go along the path after I am finding this f of 2. I know f of 2 answer here itself. First we will be completing the left subtree only, right? Left side. Yes, yes. Can you understand this? If it is like this, okay, then I will be going on with f of 1, then f of 2, then f of 3, then this f of 3 will be returning 0, then only I will be going to f of 4, then it will be returning 1. So here itself I will be finding what is the value of f of 2, right? Okay, then why should I again go here also and find what is the value of this f of 2? Can you understand this? So instead of that, if I take into my memory, okay, in my memory, like f of 2's value is this, then we will be not going to this part itself. Can you understand this? So in this case, I want to just keep them in my memory, right? So in this case, I will be using what? Hash map or dictionary in Python. Hash map will be in Java and map in C++, and dictionary will be in Python, and in C# also it will be dictionary. Okay, you can take this. Okay, so here in the key we will be taking this I value, and in value we will be taking its corresponding value. Can you understand this? Can you understand this? Right? So let me once again tell you. First of all, I will be taking the same example. So please wait, please wait. I will be making you understand this clearly so that you can understand this. So see here, this is the hash map. Okay, now I will be taking what? F of 1 here, right? F of 1. Okay, then I will be taking what? F of 2. Again I will be taking what? F of 3. This f of 3 will be found out here. What? 0. Then I will be just putting here as 3 is 0. 3 is 0. Okay, and it will be returning what? 0. Now here comes what? F of what? 4, right? 4. And this 4 will be returning 1. This is the base case. This is the base case. So we don't want to include in my hash map. Also, if you include it, that's no matter. Okay. Okay. For hats of now, I will be including here. 4 is 1. But just know that for base case, it is not necessary, because base case will be however returning it. So you can put that in the top, or else you can also put the hash map in the top. Don't worry. Okay. So let me take this. So this is your correct only. Now it will be returning what? 1. Now this 1 will be going to what? 1 will be going to 3 again. F of 3. So instead of going and checking whether this f of 3 is equal to 0, I can tell from here itself. Okay, you can also put If the current element is 0, then return 0 in the top, or else you can also put if the dictionary containing the current index is 3, then return the 0. Whatever, it will be fine. Okay, so it will be returning what? 0. Okay, now here comes what? F of 2, right? Oh, sorry. When this f of 2 is returning this 1, this 2 will be mapped to 1. I forgot to say this, okay? And this f of 1 will be returning what? 1. So 1 will be 1. Hope you understand this. Now, then only it will be going to the another recursion call called f of 2. Now, when I am going to f of 2, I will be checking whether this 2, this index is present here. Yes, it is present. So I will be returning what? 1. Just return 1. So here 1 and here 1. So f of 0 will be returning what? Will be returning 2, and here 0 will be mapped to 2. So this is by using a hash map approach. So this will be making my time complexity to O of n log n and space complexity of O of n. You may ask why it is n log n. I will be telling you, because see here, I will be only traversing this f of 1 only one time, and this f of 2 only one time, and this f of 3 will be only one time, up to n times, up to n digits or n characters, right? And also I am using a hash map to insert and just access. So inserting and accessing in a hash map will be log n. For n digits it will be n log n. Hope you understand this. And the space complexity is because of, let me write here, the space complexity is because of the stack space, okay, recursion stack space, and also the hash map. So these are the two important space complexities that are included in this O of n. Okay, now let us see this code and then go for the next optimized approach. Okay, so let me give you the code. Comment this and uncomment this. Okay, now this is the next code. Just see here. First of all, I will be just taking a map, okay, a hash map, and just I am just passing this as a parameter or argument for this helper function. Okay, everything is similar, the entire code is similar, only the difference is I will be just making this line. So this line is included as new, and this line is included as new. Okay, so these are the two only new lines I have added. So just see this carefully. The base case, these are the three base case that are included here also, right? Okay, now next thing is, if the current hash map contains the current index as the key, then return the current index value, current index keys value. Okay, so that's the meaning of this line. Okay, and then the single digit, and then I want to take the double digit and check whether it is ranging from 10 to 26, and I will be going for a double, and I will be taking in the result. So these are all same as the recursion, but the only thing which I changed here is I want to put the resultant in my hash map, like the current index and the value as my resultant. So it will be key as a I and value as the result. Hope you understand this, and I will be returning the result. That's it. So it is only two lines of code will be making my program from exponential to linear, almost linear, right? N log n. So it is basically a good optimization. So it will be your better approach. Let me submit this so that it will be definitely submitted. Yes, it is submitted, right? Because we are using a hash map. Okay. So you may ask whether we can still optimize this. Yes, but you may ask how. So I will be telling you that the access time and the retrieval time or getting the value from the hash map is of what? Of O of log n, right? This log n. So whether I can optimize this log n. Okay, so we want to access and just put or get the value in a constant time. So I want to get and access and put the value in constant time. Then what should I use? You can use an array data structure. So this array data structure will be giving you a chance of putting and accessing the value in a constant time. So by using this, you can just get rid of this log n. Hope you understand this. So just I will be cleaning this paint and I will be reopening this. Wait a minute. Now let us continue with the array approach. So this is a given example, right? So it will be f of 0. Initially the index will be 0. Okay. And then, so I will be taking an array of size 4. Sorry, of size 5, because there are totally 5 elements here, right? So I will be taking a size of 5 and it will be of indices 0, 1, 2, 3, 4, right? Now, first of all, I will be going with, I can take this 1 or I can take this entire as 11, right? So I will be taking 1 alone. So it will be f of 1 and here comes f of 2, right? So this is not a BFS traversal, but it's a DFS traversal, the recursion call, right? So it will be only of f of 1. Now from this f of 1, like here, from here, I can either take this 1 or 11, right? So first of all, I will be taking this 1 alone. So first I will be taking this f. So 1, so it will be f of 2. Okay, now from here, I can take this 1 alone, right? So if I take this 1 alone, it will be f of 3. So f of 3 will be here, it is 0, right? So whenever it is 0, I will be making what? I will be returning a 0. I will be returning a 0. So here comes, I will be returning 0. Okay, so here we don't want to do anything because as I said earlier, whenever we are going with a base case or base condition, it is not compulsory to update in my memorization array or hash map, right? Okay, now from this 2, which means here, yes, I can take this 1, 0 also, right? So that's recursion call will be occurring now. So here comes what? F of 4. So this f of 4 is the last word or last character. So in this case, I will be returning what? I will be returning 1. I will be returning 1. So here also it is a base condition. So we don't want to just update in our memorization array. It is not necessary. Okay. So here comes 0 plus 1. So f of 2 will be returning what? 1. So this is not a base case or base condition. So I will be updating my index 2 as 1. Okay. Basically, this array is designed on the factors of the parameters. I will be telling that while I am teaching the code. Okay. So how many factors are affecting the current recursion call will be of that dimension will be this array. Okay. I will be telling this once we are entering to the coding part. Okay. Now again from this 1, I can go for what? I can go for f of 3. Again this f of 3 will be returning what? 0. Right? F of 3 means this 0, right? Okay. So 0. So 1 plus 0 will be what? It will be returning what? 1. So this will be updated as 1. Okay. Okay. Fine. Now again I will be going for f of 2. From here I can take what? This 1 and 1. So I will be going for f of 2. Right? Now while I am going to f of 2, I am just checking whether this second index is not equal to -1. Yes, it is not equal to -1. So I will be returning what? What is the value of this second index? So it will be 1. So 1 plus 1 will be returned of this f of 2 as 2. Sorry, f of 0 as 2. And this 0 index will be updated as 2. Can you understand this? Yes. So my final answer will be of 2. Okay. So my time complexity will be reduced to O of n, whereas in my hash map, okay, it will be of O of n log n. Fine. And my space complexity will be O of n, because we are just taking this auxiliary stack space or a recursion stack, and also we are taking a array of size n. Okay. So this is my time and space complexity analysis. Now let us go to the coding path. So see here, this is the coding. So basically here, what are the things that are affecting our current recursion? So it is only this index, right? This index I. Okay. So it is of only 1. So that's why we are taking one dimensional array. If 2 parameters are affecting, then we will be taking 2D array. If 3 parameters are affecting, we will be taking 3D array. Okay. So basically here there is only one factor is affecting. That's why I am taking 1D array and filling with this with -1, because there is no case in this program we will be getting a -1 as an answer. We will be getting a least of 0 or a positive number. That's why for differentiation I will be taking a -1 as my default value. For checking whether if it is not -1, then it is already occurred and I will be returning that. Okay, so I will be telling here. So that basically we are just making sure that to include this line. So this is the different line. So here I will be checking whether the current index of the memoization array is not equal to -1, then I will be returning that memoization array's current index value. Okay, if not after this entire process, these processes are same as the recursion. Okay, after this entire process I will be storing the current index value of inner memoization array. Okay, and I will be returning it. So hope you understand this entire code. So if I run this, it also will be submitted successfully, because its time complexity is just O of n, right? So it is basically a efficient approach than the hash map approach. Fine. Now let us go for a next approach called tabulation approach. So I will be telling you why we are just going with the tabulation approach. So see here, what are the things that are affecting this space complexity? So I can say the factors that are affecting my space complexity are: one, this is the array, this array, memoization array, plus this recursion stack, right? So stack. So these are the two things that are affecting my space complexity. So if I optimize this array and this stack, then the space will be of constant space. Okay, so that's why I am just making sure to make this recursion into a looping. Okay, if I make this recursion into a looping, then my stack space will be empty, right? So it will be a part of a space optimization. Now let us see the tabulation method. So this is the code of a memoization method, right? Now it's time to see the tabulation method for the same example, 11106. Okay, fine. Now how to make or how to convert from a memoization to tabulation? So it is as simple as possible. So what are the factors that are affecting? It is only one thing, the index. So we want to take a corresponding 1D array of size n. Okay, so here I will be explaining this. So first of all I will be taking a size of n. Okay, just listen this. There will be a point to be listened carefully. Okay, now this is one of the base condition. What is this? It is when the current index is equal to the s dot length of, then I want to return 1. So this is one of the base condition, right? So this is one of the base condition. So if I make indices, so 0, 1, 2, 3 and 4, so these are the indices of the current array. So I was taking this current array. Okay, now here comes only 4 indices, but we want a I of 5 also, right? So I will be making another slot as -1 and making this as index 5. So I will be taking an array of size n plus 1. So I will be taking an array of size n plus 1 and making all elements to -1. Can you understand this? Because we are just including what? S dot length also. For this also I want to allocate one separate space. Hope you understand this. Now at this point I was returning what? 1. So here I will be updating as 1. Okay, so whenever in a memoization method, if you are doing a bottom up approach, then in tabulation method you will be doing a top down approach. If in your memoization method you are doing a top down approach, then in tabulation method you will be doing a bottom up approach. So this will be a reverse manner. Okay, always. Fine. Now that's why I am going from what? From last to first, but here I was iterating from 0 to last. But in this tabulation method I am going from last to 0. Can you understand this? Okay, just focus on this. Now another base condition is if the current character is 0, then I will be returning 0. So this will be handled inside the looping. Okay, now we don't want to handle this. Now see here, if I is equal to s dot length of -1, then I want to return what? 1. So here I'll be returning what? 1. But just listen this carefully. In case sometimes the last character may be of 0. Last character may be of 0. It is not guaranteed that last character is not 0. So I'll be making sure one condition, like if the last character is equal to 0, then I will be making my memo array of this last front index, which means n minus 1th index as 0. Can you understand this? Why I am putting this condition? Basically, it is also 1 only. Initially, it will be 1 only. But in case of last character is 0, then it will be also 0, converted to 0. Okay. Now, next condition is if memo. So this is not a case while converting into tabulation. We can left over it. Okay. Now here comes what? Single. So here comes the logic. Whenever there is a logic, then we want to write a for loop. So for in this will be from where? We are starting from this 3 only. We are starting from the index number 3 till 0. So 3 will be represented as far as n minus 2. Okay. Up to what? Up to 0. Fine. Yes. Now what is a single? So inside this only we want to also reconstruct this logic. Let me highlight this with this orange color. So this logic. Okay, what is the logic? So if the current character will be character 0, then what should I do? I should be making my memo array's current character also as 0. Can you understand this? Yes. Now in next step only we are going to execute this conditions. So let me execute these conditions. So single will be what? Will be of memo of I plus 1. That's it. Here we are going for a recursion call of decode of I plus 1. Okay, recursion call. So here we are just making what? Memo of I plus 1. That's it. Simple, right? Okay. Now next we want to just put these 3 lines. These 3 lines here. Let me highlight this. These 3 lines here. Okay. Then we want to continue with the last line. So last line will be inside this condition. I will be making my double as memo of I plus 2 inside that condition that I highlighted in this blue color. Okay. And then at last I will be making what? Memo of I is equal to single plus double. So single plus double. Okay. And then after this, once this for loop gets terminated, ended. Okay. Then I will be returning what? I will be returning memo of 0. That's it. So this is my entire code of tabulation looks like. Now let us try run this. Okay. For the example of 11106. Okay. For this example, let us try run this so that you can understand this clearly. So -1, -1, -1, -1, -1, and then -1. Okay. So this is my initial array. Okay. And at top of this, I have already told you what will be the base condition. So I'm just checking whether I just make my last index as 1, right? So I made, and then I want to check whether I want to make my last index front index as also 1, and then I want to check whether the last character is 0. Whether the last character is 0, it is 6, right? Let me write this once here. It is 6, right? So we don't want to do anything. Just leave it. Okay, right. Now go to the next. So here. Okay. So now 0, 1, 2, 3, 4, 5. Now third index. For this third index, here also I want to take the third index, right? While iterating, now the index value will be 3. Okay. What's the 3? It is 0. So this condition will be satisfied, right? Whenever this condition is satisfied, we want to just continue. I forgot to write this. Either we can continue this or we can use a else condition here. That's your wish. Okay. So I will be continuing this to the next iteration, right? So I will be making this as 0 and to continue with the next iteration. Hope you understand this. Now it comes to 2. Okay. What is a 2? It is 1, right? So 1 is not equal to 0. It is not equal to 0. So I will be continuing the rest of the things. So single is equal to memo of I plus 1. So memo of I plus 1 will be 0, right? So here comes 0. Then whether this 1, right, this 1 and this 0, which means 1 and 0, right, this is in between this condition, or it satisfies this condition. Yes, it is satisfying the condition. Can you understand this? I and I plus 1 will be the substring of this I comma I plus 2, right? Can you understand this? So the same condition, whether this 1 and the 0 combinedly satisfy my condition. Yes, it is satisfying the condition. Then what should I do? I should be taking my I plus 2 value, right? So I plus 2 value will be 1. So 0 plus 1 will be 1. So this will be made as 1. Can you understand this? Now it's time to go to the first index. So first index is 1. So it is not equal to 0. Yes, and we will be taking what? Single as I plus 1, right? So I plus 1 will be what? 1. So here comes 1 plus whether the double condition is satisfied, whether 11 is valid. Yes, it is valid. So double condition is satisfied, and I will be taking what? I plus 2. So I plus 2 is 0. So 1 plus 0, which is equal to 1. Okay. Next, I will be going for the 0th index. Now the 0th index is 1. So I will be just checking the condition whether it is equal to 0. No. So I will be continuing, and I will be taking a single as memo of I plus 1. So memo of I plus 1 is 1. So I will be taking here 1 plus whether the double condition is satisfied, whether 11 is correct. Yes, it is satisfying the condition. So I will be taking what? Memo of I plus 2. So which is equal to also 1. So 1 plus 1, which is equal to 2. So this will be made as 2. Okay, this will be made as 1, and this is also 1, right? Okay, now at last I will be returning what? I will be returning this memo of 0, which is equal to 2. Can you understand this? So this is going to be my dry run, and then my time complexity will be O of n, and my space complexity will be also O of n, because we are using what? This array. Okay, now let us see the code quickly, then we can go with the space optimization technique. So this is my code. So I will be taking extra one element, okay, or index. Now I will be just checking whether the last character is 0. If it is 0, then I will be making this as 0, else I will be making this as 1. Okay, now I am checking whether the first character, so this is going to be my base case. Okay, if the first character is 0, then I will be returning what? 0. So they are already given in the question. If the first character is 0, then we will be returning 0 in all possibilities. It is impossible for a valid case, right? Then I will be traversing from n-2 up to 0, and I am just checking whether the current index is 0. If it is 0, then I will be making my current memoization arrays index as 0. Okay, there I wrote as memo. Here I gave us a dp. That's it, and I will be continuing it. Fine. Now single is equal to dp of I plus 1. Instead of what? Instead of that function call, instead of that recursion call, I made here. And then double and these 3 lines are similar because it is a condition, right? So it will be same as a memoization. Now double digit is equal to dp of I plus 2. Here you will be seeing what? Decode of I plus 2, right? Okay, fine. Now at last I will be making my current in this value of the dp as the sum of single and double digit, and at last I will be returning what? dp of 0. So this is going to be my tabulation code. Now let us go to the space optimization code. So what is meant by space optimization? So we are just going to take whatever the space is required instead of taking the entire array. Can you understand this? Yes. So let me go through here. Space optimization. So this is a solution for the tabulation method, right? Now we are going to do a space optimization. So already I told you that to do a space optimization, we will be taking a smallest number or fixed length of the array, right? Or else you can also take a variable structure. Okay, so see here, for example, if I have 11106 as my given string, then I will be taking what? -1, -1, -1, -1, -1, -1 up to 6, right? But we only want 2 space, right? 2 space. So that's initially work like -1 and -1. So this is going to be my array. Okay, now I am going to demonstrate it. Fine. Now at first at first I will be checking, I will be making my last index as 1. Obviously here also I will be making my last index as 1, right? I'll be telling you by using this to just come up with the approach for this space optimization technique. Okay, now I'm checking whether the last element is 0. No, it is not a 0, right? So now I will be making here also 1 and here also 1. Just listen this carefully. I am just explaining you. This is not the space optimization technique. Okay, I'm just making you to understand how we are going to do. Okay, now I will be starting from where? I will be starting from 3. Okay, now what is the third index? It is 0. If it is 0, what should I do? I will be making my current index as 0, right? Current index is 0. So here I will be making my result as what? 0. Okay, now it will be what? 2. The current iteration will be 2. Now here I will be going here, right? Here I will be going here, so that I will be having what are the next two values. It will be 0 and 1, right? Okay, here also I will be making as 0 and 1. But how? See here, before this, the previous iteration, it was like this. It was like this. In next iteration, I want to make like this yellow color mark. So it is like I want to swap each time once, right? Which means I will be swapping this to here. Okay, so it will be 1 again, and this result to here, so it will be 0. Can you understand now? Yes. Now just see here, this yellow color box and the one in my array are same. Yes. Now again, just come up with me. Now it is what? 2, right? What is in the second index? It is 1. It is 1. Now for this I will be taking what? Single as I plus 1. I plus 1 means what? Here it is 0. Here I want to take the 0th index, not I plus 1. I want to take 0th index. So 0th index is what? 0. So in result I will be putting 0. Okay, result is equal to what? It is single plus double digit, right? So that's why I'm putting 0 here. Plus. Whether 1 and 0 are valid. Yes, it is valid, right? So I will be taking what? I plus 2, which means here. So here I plus 2 means what? I will be taking the first index. I will be taking a first index. So it is what? 1. So I will be taking what? 1. Can you understand this? Now which is equal to result will be 1. Okay, now my iteration will be what? Will be 1. Change it to 1. In this case, now I am going here, right? Here also it will be updated as 1, right? 0 plus 1. So now I will be taking two elements that are in my green color box, because we only want I plus 1 and I plus 2, right? So here also I will be making this 0 to be going to this 1. So my new array looks like 0 here, and this result will be replaced in my 0th index. So it will be 1. Again my result will be bring back to 0. Okay, or you can bring back your result as -1, whatever. Okay, so I am just bringing back to as 0. Okay, fine. Now again we are going with what? First index. So it is 1, right? It is not equal to 0. So we can continue. So what will be the single? Single will be what? This next index I plus 1 value. So I plus 1 value is what? 1, right? So I will be making here 1 plus, and here also this result will be made as 1. Okay, and then whether this 1 and 1, which means 11, can be a valid string for the 2-digit number. Yes, it is valid. So I will be taking what? I plus 2, which means this 0, right? I plus 2 means this 0. So I will be taking 1 plus 0 here. Similarly, here also I will be taking what? The first index. So it will be plus 0, which is equal to 1. Result is 1. Can you understand this? Now my iteration will be what? 0. Hope you understand now. Yes. Now I will be making what? This as 1. This will be updated as 1. And here also I will be making my this 0 as 1. This will be transferred here, and this result will be transferred here. This is also 1. So my new array will be looking like 1, 0, and result will be what? 0 again. Can you understand this? Now we are 1, 1, right? 1, 1. Sorry. Okay. Now we are at what? 0th index. So 0th index. At 0th index it is what? 1. So I will be taking the I plus 1, which means from here I will be taking this. So it will be 1. So 1 plus, here also I will be taking what? This 0th index. So it will be 1. Now whether this 1 and this 1 are can form a valid double string. Yes, it can be formed. So 11 is a valid string, right? So I will be taking what? I plus 2 also. So it is also 1, right? So it will be 1 plus 1, which is equal to 2 here. And here also I will be taking what? The first index value. Can you understand this? Yes. So here also it will be 1 plus 1, which is equal to 2. Okay. Now again, this will be going to minus 1. And here also I want to do a swap, right? So this will be changed to 1 and this will be changed to 2. Now at last I will be returning this array's 0th index. Can you understand this? So basically here the index I plus 1 is the 0th index. Okay, and the index I plus 2 is similar to the index of 1. So this is the space optimization technique. So here I'm just taking a size of 2, right? Array of size of 2. Or you can also take two variables to keep track. Okay, so by doing this, my time complexity will be of O of n and space complexity will be O of 1. So this is a space optimization technique. I'll be showing this in my code so that you can just understand this clearly. Okay, so these steps are similar to the previous one, and here comes b is equal to 1 and a is equal to, whether the last character is 0, then it will be 0. If the last character is not equal to 0, then it will be 1. Can you understand this? So here the b is like acting like the index 1. So here I wrote, right? So in my explanation, so this is acting as a and this is acting as b. Now hope you understand. Okay, just fix this in your mind and come back to the coding part. Okay, now see here, if the 0th index is 0, then I will be returning 0. Okay, and then I'm going to iterate. In that I will be taking the result as 0 and I'm just checking whether current character is 0. If the current character is 0, then what should I do? I should be just doing a swap and just continue. So I am just swapping as b is equal to a, which means I want to just make the a's value to be stored in the b, and a will be of having a value of what? 0. Having a value of 0, or you can also put as result. Both are fine because result is also 0 here, and then you will be continuing. Okay, now next step, you want to take a single as a, because I plus 1 is correspondingly equal to the a as of now in the optimization technique, space optimization technique, right? Now double digit will be 0 initially, and I am taking the substring of I and I plus 1. Then I am just comparing whether that substring is greater than or equal to 10 and less than or equal to 26. If it is so, I will be taking the double digit as b, and after that I will be taking the single and the double digit sum in my result. Okay, and I will be doing a swapping. So b is equal to a and a is equal to result. Hope you understand this. Now at last I will be returning the a value. So here, to just make this in an optimized way, or just look the code compact, you can just make this as not equal to 0. Okay, if it is not equal to 0, instead of these 3 steps, I can include these steps. Okay, so just cut this and copy here, paste here. So now my code is looking somewhat compactable, right? So initially my result will be 0 anyways, and then here also it will be 0 if the current element is 0. Can you understand this? Okay, let me submit it so that we can find what is a mistake in my code, or it is a fully correct code. Yes, it is a space optimization code. Okay, so here the space is of constant space because we are only using what? Variables. Okay, variables and the fixed array size are always a constant space, while the array that are changing with the number of size or n value, then it will be of variable size. So I am glad to just start with a DP topic. So this is my first program for my DP topic after the Fibonacci series. Okay, So hope you understand this problem clearly. If you don't understand, just comment below where you have not understand. I will be just posting another video. Okay, so that's not a case. So just go once again with this problem so that you can understand this DP clearly. I have put my 100% effort to just clarify this entire problem. That's why it is of a lengthy video. If you really like this video and subscribe to my channel. Don't skip any videos in this playlist because all videos will be helpful once you are appearing for the Zoho interviews. And to know about these kinds of algorithms and DP algorithms, I'll be posting soon the DP algorithms. So just go and watch in my YouTube channel. Thank you.